today on how it's made. Airstream trailers. Horseradish. Industrial steam boilers. And deodorant. In 1931, Airstream founder Wally Byam sold plans to build your own travel trailer. In response to a growing demand, he decided manufacturing was the better way to go. He then introduced the Airstream trailer, with its familiar modern design that has withstood the test of time. The Airstream trailer is a recreation vehicle that you can take to the most remote areas, yet still enjoy a fully functional living space. They can also be hooked up to outside services, so you can stay as long as you like in the comfort of home. To start, an operator puts a sheet of aircraft-grade aluminum into a press that punches the rivet holes. A worker then rivets the sheets together to make the walls of the trailer. Here, they're assembling the end shells, the rounded end sections for the front and back of the trailer. They apply sealant to all the seams. Technicians then rivet the two ends to the components that make up the trailer shell, including the floor, the walls, and the roof. A worker uses a router and a template to cut out window openings from the walls. He puts the windows in the openings and secures them in place. Another worker applies a weatherproof sealant to all the interior seams, then smooths it out to ensure good coverage. Using a crane, they lower the shell onto the chassis. At this point, they thread some of the wiring into the shell. Next comes the plywood floor, which a worker attaches firmly to the chassis. Another associate puts the door in place. He rivets the door to the shell. He takes extra care to protect the aluminum from being damaged by the force of the rivet gun. The trailer then goes into a rain test booth that simulates hurricane-strength rain. The test lasts about an hour, during which a technician makes sure the shell is watertight. Next, they apply a water-based adhesive to the interior and install insulation throughout the shell. Now they bring in the interior skin. It's the same aircraft-grade aluminum used on the outside. They trim the walls for the window openings, then lay down the vinyl floor covering. An installer trims the vinyl and uses the old-fashioned way to make it snug against the shell, because a standard carpet stretcher would poke holes in the vinyl. A worker installs the fiberglass shower stall and hooks up the drain and plumbing. He cuts a hole in the fiberglass, then installs all the shower control components and the shower head. He finishes off this residential-style shower with a frosted glass door. Next, they put in the convertible couches and beds and all the other amenities of home, including a gas stove. Finally, a technician performs quality control checks to make sure the electrical and mechanical systems work flawlessly. Only then is an Airstream trailer ready to hit the road and continue the time-honored tradition of discovery and adventure that makes this iconic recreation vehicle an American original. Horseradish has a hot history. The ancient Greeks used it as an aphrodisiac. They also rubbed it on sore body parts to alleviate pain. During the Renaissance, eating horseradish made its way from Central Europe to England. By the late 1600s, it was customary among the British to eat horseradish with beef and oysters. At the root of this hot condiment is a root. You peel away an outer skin to access a thick white flesh. Chewing or grinding the flesh releases enzymes which produce horseradish's heat, the plant's natural defense mechanism against predators. Horseradish is a leafy, flowering plant with a thick central root called the mother root and smaller offshoots called sets. After culling the mother root, farmers replant the sets, each of which will spawn a new plant. At harvest time, the first farm machine chops down the plants to ground level and rakes the leaves out of the way. Then, a horseradish harvester digs up the roots. As the roots bounce onto a mesh conveyor belt, most of the soil breaks off and falls back onto the ground. You have to keep horseradish cold to keep it hot, so the roots go directly into a cooler. The temperature is just above freezing and the humidity high, so the roots retain their moisture. To grind them fresh from the field would produce horseradish with a grassy flavor, so the roots spend about a month in the cooler. Only then are they ready for processing. At the horseradish factory, a machine washes the roots in cold water. Then a conveyor belt runs the roots through a final rinse. Workers carefully inspect the roots. They pick out any debris and discard any dark roots that would sully the whiteness of the final product. Next, the roots travel to the automated grinding system. The conveyor belt has built-in scales that control how much goes into the grinder at a time. The grinder works like a giant food processor. While grinding, it automatically feeds in a specific amount of vinegar. This stops the enzyme reaction, preventing heat from escaping. The grinder also automatically adds water and salt brine. The salt adds flavor and keeps the horseradish from browning. Next, the horseradish moves into a blender. This is where the factory adds the extra ingredients for specialty flavors, such as fresh cream for cream-style horseradish. A pumping system transfers it from the blender to a holding tank. Inside the tank, mixing blades continuously turn to prevent the ingredients from separating. En route to the filling station, the inside of every single glass container gets a blast of air to blow out any debris. The filling process is entirely automated. The machine grabs each container, aligns it under a nozzle, then squirts the horseradish inside. The filled containers move on a conveyor to the capping machine. There, a spinning head descends, screwing a plastic cap to the container. Next, the containers move to the labeler. It applies glue to the back of the labels, then slaps one onto every container. From there, the containers go off to cold storage until shipping time. Shipping via refrigerated truck, of course. Industrial steam boilers heat water to produce steam to do such things as sterilize surgical instruments, cook food, heat or humidify buildings. They're even used for dry cleaning. The water inside an industrial steam boiler is heated by natural gas, oil, or electricity. Industrial steam boilers are usually found deep inside buildings, where they inconspicuously create valuable steam and heat. It starts with a plasma torch that cuts holes in a solid sheet of steel. The thickness of the steel used depends on the operating pressure of the boiler. Using a hydraulic bending machine, a worker shapes the metal into what will become the inner shell of the boiler. This inner shell will contain the water that gets heated inside the boiler to create steam. He stops the rolls and prepares an edge of the shell for welding. He continues shaping the metal to a preset diameter, and then he grinds the other edge to prepare it for welding. The shell shape is now fully formed and ready to be welded closed. A submerged arc welding machine deposits a special granular material that protects the weld from air contamination. He removes the protective granular material, leaving behind a perfect weld. Next, a worker welds what's called a boiler head to the shell. He fits steel pipes into the boiler heads, located at both ends. He welds the pipes securely in place. Workers then insert a combustion chamber into the shell. Later, a burner used to heat the water will be fitted into the combustion chamber. A worker then tests the fully assembled pressure vessel, as it's now called. He fills the space between the combustion chamber and the shell with water to ensure it doesn't leak. Workers then wrap the pressure vessel in insulation to help the boiler retain heat. They wrap an outer jacket around the pressure vessel and secure it in place using sheet metal screws. All boilers then receive a blower, which feeds air into the burner and the combustion chamber. Next, a worker attaches what's known as a water column. This apparatus supports various control devices and sensors, as well as a visual indicator that shows the water level inside the boiler. A worker connects the electrical control panel so he can test the safety and operation of the boiler. He powers up the unit and fires the burner that is installed inside the combustion chamber. He opens a steam outlet pipe on a test line and makes sure all the control devices, including the water level indicator and the blower, are working properly. This boiler passes the test. It generates the correct amount of heat and steam. Finally, a worker applies the appropriate labeling on every boiler, whether it's a smaller unit, the type used in a dry cleaning business, or one of the larger boilers used in a food processing plant. Before bathing became common, people used heavy colognes to mask unwanted odor. It wasn't until the late 1800s that chemists created the first commercial deodorant. Today, deodorants are available in a variety of forms, from natural alternatives like body crystals to antiperspirants that use chemicals to reduce perspiration. Almost everyone applies deodorant at some point during the day. Convenient packaging helps make application easy. First step to making deodorant: mixing up the batch. Workers pour a blend of ingredients into a kettle mixer, then add powdered wax, the main ingredient that holds everything together. They also add silicone for a smooth texture. Steam heats the mix to 75 degrees Celsius, melting the ingredients. A standard recipe for deodorants includes wax, active ingredients that prevent perspiration, dimethicone, a blending agent, silicone, and fragrance to mask odors. Deodorants, like all personal care products, must meet strict quality control standards. The chemists in this plant's laboratory perform a variety of tests to ensure their product meets the highest standards. To make sure that the product has the right consistency, this chemist will perform a viscosity test. She stirs a sample at a constant speed, then verifies that the force required is within the accepted range. These containers will dispense the deodorant. They're mechanically unscrambled on a rotating platform that sends them spinning into individual pockets. Sensors overhead detect the ones that aren't lining up properly. A blast of air sends them back onto the platform to repeat the process. Now that they're all right side up, they move along to the filling station. There, a system of levers raises them up to align with filling nozzles that dispense the mix. A system of rotating wheels keeps the containers moving. One wheel conveys them to the next for filling, and then a third wheel leads them out. It's best to fill using hot mix that flows freely. But the deodorant must cool in order to harden. An overhead rake evenly lines up the containers inside a refrigerating tunnel. Once it's full, workers set the cooling system to 14 degrees Celsius. The deodorant will remain here for several hours. Next, chemists perform a hardness test on a cooled sample of deodorant. A force meter measures the amount of pressure required to crush the sample. It has to be just right. Too hard, and the deodorant crumbles without spreading. It must be able to flow smoothly out through this perforated dome that will cover the deodorant. Each container gets one, over at the doming station. Again, a system of revolving wheels works together to convey the containers through the station. At the center wheel, cappers overhead lay the perforated dome on top of each one. The containers then move to the next station, where they each receive a strip of adhesive plastic that covers the dome's surface. A safety seal that protects the deodorant. Back to the doming station. The containers pass through once more, as the cappers now snap a plastic cover onto each one. Now they're ready for the final step, labeling. The containers roll past a plate that lifts off adhesive labels from a continuous strip and applies them. A brush smooths over the labels, and that's the final touch. Now the deodorant is ready for shipping to customers. Good things do come in small packages of all kinds.